The following content has been provided by RWTH Aachen University.
All right. Hello and welcome everyone to iOS application development. We'll continue today with working with the web that you already started talking about last week. And we'll continue with our example there, getting the image of the day from NASA and what we all need to do to display those information. So a short recap on that. The goal is to have our screen with the current image of the day, the title of that image, and the description that is associated with that. NASA offers there an API where you can access those information from the web, and we want to get that and unpack it nicely so that we can use it in our app. So the steps that we need to do for that. First is that, or what you already talked about here, was creating an URL. So how do you create this in Swift that it is sufficient for all the requirements, does not use symbols that are not allowed, and how can you add your components to that so that you have your API key and the value that you want to pass over, and that you can create that quite easily with the components. Then, using the API keys to get that information, to start that query, get it back. There you talked about asynchronicity, how you can wait for a process that takes some time to return the data that you requested, and how you can trigger that in Playground or your Xcode project. And that's the place where we will start then today. You want to not just have a bunch of data, but you want to have actually in a Swift model that you can then easily work with and use the different components that you queried from the web. And in order to use that and get that model, in this case we'll work with Json, which is also, as you know, mostly used to represent data that you get online, query online. And then last but not least, we will use all that to update our UI so that we have everything on our screen. So last week you already spoke about creating the URL and requesting the data. So now we'll jump ahead and think about the model that we want to use. So when you requested the data and just printed it out as a string, this is what you what you got back. So you have essentially a set of string pairings that look like a dictionary and also behaves in the same way. You have, for example, the date. You have an explanation for the image. You have an probably high definition URL, what media type, whether it's an image or the title, what am I seeing, and URL to the or in general image that from the picture of the day. So that is something you get back. And of course, you could have now create a dictionary where you have just string pairings and use them in Swift as well, that every time you then look for the key, think, what do I want to do with that? The date, okay, this is a date, so the string that I'm getting there as well, I want to pass it as a date. Of course, you could do that, but it's a hassle to use, and it's not really then very safe to continue using that data. So instead, the goal is to have a Swift model that we can map this information to. And first, ignore the lower part here. What you just need is a struct that is also codable, so that it supports coding and encoding data. And here you can specify the components that you want in your struct. So here, for example, we have a title, description, URL, and a copyright, for example. You would see that there is no copyright mentioned here in the information that we got from the website. So that is why it's here also an optional, meaning that if that exists, then it will also carry over in your model. Otherwise, this will be set to nil. And here, title and URL also already exist here as well. So they, during the decoding, will map directly to what you have in the data that you received, and will map the values to your model there as well. And everything else that does not exist, so the HD URL, for example, or the media type, if it's not mentioned here, it will just ignore during the encoding, so it will drop that information. But one problem that we have here, or that we created here, we have here a description on the one hand, but it's named explanation on the data that you received. So, of course, if we create this setup, we could have already just named that explanation and it will automatically have worked. But maybe it's a model that you're working with that has already specified names, or the names make more sense in the project that you're using it in. So what you can then do is use or specify the coding keys, what matches, what name of the data matches the name in your model. And this is what this enumeration does. So in our struct, we add an enumeration with the coding keys that also has the protocol for the coding keys, mentions that this is the component there. And there you list, again, the names that your keys should refer to. So we have our title, the URL, and the copyright. They are essentially just repeated here. Those are the keys that are needed. And then you have the description, which you have in your model, but that is then matched with the explanation from your data that you're receiving. And with that, you have essentially your model description of the elements that you want to use, and you can specify in what format or what data is in that. So you have a URL instead of a string, so that you can directly continue to use that and have this type safety moving on after the encoding had worked. So that now created our model that we want to fill with the data that we get back, and that we can then continue working with. But now the question is, okay, how do we get from this string data that we received back, how do we actually get then a model object? So, and that is with the Json decoder. You already spoke a little about code encoding and decoding and the various methods that you have there, and that for a decoder, the decode method is the central method that is required, where you then try to create an object out of the data that you have. So going quickly over the, since it's the first time now we have the code today, we have our components that we initialize with the general URL that we want to create, and then we add the query items. So for the API key, using just this demo key, and the date that we want to query the data from, and creating individual query items for each of those key value pairs. And with that, this component set up, we start the URL session, and since that is an asynchronous call, we need to add the await keyword. And since it can also fail, we are also using or specifying here the try to signal, okay, this is something that might not work. And from there, then we're initializing the Json decoder. And after we've checked here that the response is a success, so casting this as an HTTP URL response, and the status code is 200, which is, yeah, everything worked. We got the data. Then we're trying to, so yeah, here we have the try keyword, decoding the data that we get back as our photo info. That is the model that we just described. And just use the self to refer back to the description, essentially, of your model there. So all the components. So we try to decode that and assign it to a constant with the photo info name. And if all of that worked, so all of this is in this if-let structure, then we can print out our photo info. So the decoding is really simple, just initializing the decoder and calling the decode methods that we have here. So here it is just, yeah, quite simple because it's only one layer of JSON syntax, so there are no nested nested dictionaries in there. Of course, it then gets more complicated. The more complicated the data is that you get back as well. But very often, the APIs that you get allow you to get very specific elements that are then simple enough to be represented in your data or in your code that you can easily decode those and then reconstruct the model that you want to have. So. Now this setup that we have here is, yeah, just the general process of calls that you have, but we have here still this task where we specify, okay, this is something that is running asynchronous. Everything else around it is still a synchronous setup, so everything's running one after another. But everything we have here so far is something that belongs together. So specifying the component and then doing something asynchronous and where I need to manage all of that doesn't really make sense. Usually you just want to have a function that you're calling, okay, get me all the photo information, and then I can continue working with that. So if we move all of that in a function, we can, yeah, have here our function fetching the photo info, and we want to get a photo info back. And now everything is just copied over, so creating components, performing the or calling the session, and decoding the information that we have, and then returning the photo info in the end that we unpacked. But yes, this won't work right out of the box because, again, we have here the problem, okay, this is something that is running asynchronously, but here we're not specifying that it is a task. So how you can do that is just calling or making clear that this function overall is doing something that is asynchronous. So specifying for the function, okay, this will take some time. You need to handle outside that you're waiting for that or calling it in the appropriate manner. And how you do that is specifying the async method keyword in your function definition. That you specify there, okay, this method has some asynchronous properties. If you call this, yeah, be aware of that, that you need to wait for that. And that takes care essentially of our wait problem here. The other keyword that you need to add or have to add is that it also throws, meaning that it can go wrong. There can be problems with this, and this method can carry out or carry over an error. So if this, for example, fails, if our URL session for whatever reason yet doesn't work, returns an error to us, since we are not handling this error right away here, with the throws, we just specify, okay, this method or this function will throw this arrow further to the one calling this method in the end. So this setup still is not complete because we specify that we will return a photo info, but we're only returning it if everything here worked. So if we were able to really unpack everything that we got back from the website, and we were able to decode into our photo info object and then return it. So one way we could handle that is, if that didn't work, we return nil and specify that this is an optional, so it might return something, but it might not. But another way is that you check whether everything worked and then throw an exception if if there was a problem with that, so that you can make clearer, okay, what you were trying to do, getting the information, that didn't work, so you need to handle that. And okay, so there is the no return if this part is false. So that is the problem there. So, and the way you are doing that is you can specify an error with the appropriate information you want to pass on. So, for example, if we create an enum with a photo info error, conforming to these protocols, and the only case we have here is that the item was not found, or there was a problem with the data, or whatever we want. And instead of trying to assign everything directly, we're using a guard statement to check whether we received data back. And if that did not work, then we throw back an error that then the surrounding function needs to handle, or is aware of, okay, there was a problem, that item not found is probably not the best name here, maybe something the no data received, or session, the response was wrong, or whatever. Something that you then know how to handle. But if that guard works, then we can try to here unpack everything, decode the information that we have. And if the decoding does not work, since we are not handling this error here, if there was this try does not work, this error would be rethrown by our function, so that the surrounding function knows, okay, there was a problem with the decoder. It's all about that you know, okay, which part of my function really created then the problem, that you can look for a solution there in your surrounding app. So that is it about the how to decode the information that we get back. Now for the updating the UI, it's essentially integrating everything into your app. So what we could have in our viewDidLoad method, so once we start our app and everything starts up, we try or first start a task, because we want to call our asynchronous method, and we try to fetch the photo info, and to do that, yes, we need the keyword await, because that is the thing that runs asynchronously, and we try it because this function could also throw an error. And if that worked, then we update our UI with the photo info. And if that doesn't work, then we update the UI with our error. So there are functions, one updating UI that takes an argument a photo info, and there is an updating UI with an argument that has an error. And so this function then calls the error, so we can set up our properties specifying, okay, there was an error with the data retrieval, with the image retrieval, or whatever. In the update UI, what we need to do there is we have all the textual data so far. So we have the title, we have copyright if that existed, we have the explanation, and we have the URL to the image that we want to show. Well, we just don't want to only show the URL, but the image itself. So there we call a method fetch image that we haven't specified here. If you can look at the book for more information on that method. And again, since it's something we are calling from the web, and we are not sure whether A, it will work, or B, how long it will take, it's again something that runs asynchronously. So the try await is also happening here. And then we can set all the properties in our UI. So setting the title, setting the description, and setting the image that we have. And that is quite interesting if you know how it worked with iOS and so on before, because setting really the contents of your UI in a context that is asynchronous, so it's waiting for input, was something that was not that easily possible before. And that was because on iOS, the main thread handles all the user interaction. So that makes sure that your scrolling through a list is smooth, or the buttons reacting promptly, and so on. If you change something in the UI, you need to do that on the main thread. On the other hand, when you have some asynchronous calls, you do that on a separate thread. And if you then try to manipulate the UI from there, that didn't work. You needed to go explicitly back to the main thread to do your changes to the UI there. But this setup with the tasks allows you to combine these contexts where you have asynchronous calls where you specify, okay, here at this location, there you might need to wait for a longer time for something. So suspending the actions at this point, waiting for the results, but then without having to specify now there's a thread switch, you can change the UI properties as well without having to navigate all that yourself. So that is something where it makes that all a little bit simpler. So and again, if there was a problem here of fetching the image, then you can again react to that error and specify problems in terms of, okay, couldn't get the image or whatever. And with that, that was then the last step that you needed to get the data and display it on in your app that you have the image, title, description, whatever. Any questions about this process, getting information from the web, querying that, waiting for responses? All right. Then, let's talk a little bit more about concurrencies. So how you handle all these information, what possibilities do you have? So we've used now mostly the task. And we'll see why that works in some sense. But we'll also look at the more lower level way how you can manage and handle all of that yourself. So first, of course, there is multi-threading in iOS, that you can have multiple tasks running at the same time, and that you can shift longer running things, or things where you're waiting for something, to a separate background task, background queue, so that your main thread where you handle your UI interaction is free to respond, so that the interface does not freeze or stutters when you're scrolling through a list or whatever. So the important difference there, you have synchronous steps that are really happening one after the other. So one line of code completion, then the next following the other. And the asynchronous calls that are happening in parallel, where you can have then multiple things happen at the same time. And that is really something where when you see that your interface is frozen up, there is probably something that you should push to a background thread or handle in a task so that your main thread, the main queue, is freed up to handle the interactions. Another point of concurrency is also that you have or can have race conditions, that you have who is accessing which part of the memory, and there are elements you don't want to have multiple people interacting with at the same time. So for example, a database that two parts trying to access the same data and mess that up, that one's changing it while the other's accessing it. And how Swift is handling that is through actors. And actors essentially are same as classes before, but if you access part of these properties, you can't do that directly. You need to use, for example, the await keyword for those, and then Swift makes sure that those are handled step by step, that there is no concurrent accessing of the same properties here. And a special anchor that is often used in conjunction with a UI kit is the main actor, handling the UI input, your interface in general there. So, and that makes then sure that if you have, for example, in the task closure, that you are able to also access the UI components, because the main actor made sure that that is done separately and that everything is running smoothly, and your changes are then slotted in directly without blocking anything. So, and that also then means that from your or the way you're writing it, that what you have after the await, where the code might suspend for some time to get something or some data back, that will then run again synchronously in the context of our main actor, meaning that the context where you're calling your task is kept for your task, that you can, if you're starting that on or calling that for the main actor, then you're also executing those lines of code in the context of the main actor, that you can change the UI in this sense. Going a little bit lower and having more control, but also more things to consider, is using Grand Central Dispatch. And that is allows you to handle separate queues and accessing task or suspending task to those queues directly. So there are the various queues that are directly handled by Grand Central Dispatch, and you post essentially your task closures to those queues. And again, you have a main queue where everything that is UI related is running. That really has the highest priority. That is giving or should never be blocked by something that takes a longer time, so that your UI is responding to the user input. While background queues, you can fill up with tasks that take some time or where you need to wait for a response. And the way you're using that is that you specify for the dispatch queues what sort of quality of service you want. So background is one. You can have utility, user interaction. There are some more. And then post a closure with the task that you want to carry out here. And that is then running on this background thread. But then once you want to change something again in the interface, if you want to manipulate your UI, then you need to dispatch those commands back to the main queue. And so after this has been carried out, then here you can update the UI and do any changes that you have there. So that for GCD and a little bit about the actors. Any questions that came up for this topic? All right, because then we're moving to the next bigger topic that we have, and that is advanced data display. So what ways do you have to display the content on your screen to organize everything that you have on or want to show in your app? And so far, you've seen, for example, or talked about table views, which are very good if you have list data. So a number of elements that you want to display. Either you know exactly how much they are, so you have static table views, or you can scroll through them and have then loaded dynamically with dynamic table views. But this is only, really in scrolling in one dimension, and is then rather limited in the way that you're interacting there. On the other hand, or what is becoming more prominent, are collection views. And collection views are essentially, you can also create table views using collection views, but there's a lot more possibilities, a lot more options that you have there. So to use collection views, there are again also a subclass similar to table views of UI scroll view, and you have there a separation between the collection view and the layout that is specifying how those views are arranged on the screen and how they behave. And while a table view is rather straightforward in the way what information you're showing, a collection view is there more flexible, giving you way more options for the various setups that you have. So a couple of examples that are included in iOS already. We have the Shortcuts app, where you have these different tiles just side by side, while on the File Explorer, what's it called? Files? Just Files, I think. You have previews, some information there about the name, sizes, and dates, and have these elements arranged in a grid pattern, or for the photos where you have a general grid. But more complex one would be for the Watch app, where you have a gallery of the different faces. So you have on the one hand you can scroll vertically through different categories of watch faces, but in each of those lines you can also scroll horizontally through different representations of those. And all of that is just done or is using collection views to display those information. And they're, again, very similar in structure and style, how you interact with them, also to table views. So you have the same dequeuing of cells so that it handles what is on the screen at the moment and reuses the cells that are currently not shown when you're scrolling through them. I have the same index path system to access the information, the data that you want to display. But other than for table views, the cells, there are no predefined styles that you're using. So for table views, you can, remember you had the detail view, the title view, the accessory views that are linked to that. Instead, for collection views, you really need to specify your items and your cells directly. There are already some specific cell types. So if you have a view list cell that has content or configuration that you can use similar already to table views. So if you just want a simple one like that, you can use that cell. But on the other hand, then a table view, if you just need that functionality, is way quicker to use and to set up than having a collection view specifying there the layout just to look like a table view. For the collection views, you have, like I said, this separation of tasks. So you have your collection view, but a layout object that specifies how all elements are arranged and how they behave to each other. The view layout, the collection view layout that you use there, in general, very abstract class, but in iOS you already have a couple of predefined layouts that you can use. I think the standard one is a flow layout, so where all the elements, if it doesn't fit in one line, it automatically goes to the into the next one, and so on. So very simple structure and layout that you have there, so that you can have the grid like appearance, for example. But if you want to go further, subclassing the flow layout or creating own collection view layout class directly is very tricky. So there's a lot that you would then need to handle. Instead, the compositional layout is already a way where you can specify and realize a lot of different structures, different hierarchies, and different layouts that you can use. So if for a compositional layout, what you or the structure that you already have there is that you have items that are nested into groups that can be set up into sections. And you specify for each of those, first for the items, how do they look? So essentially your cells, what components are in there. And then for the groups, how do these items behave inside one group? Can also have groups inside of groups, so you can have really there in nesting. And then also for the sections, how should they behave? So that you really then combine different visualizations in terms of I can scroll through the whole list, but for this section I can also scroll horizontally through them, and these are large items and smaller panels that I can have.
This content was provided by RWTH Aachen University.